To fix our movement problem from the last video, in this one I'm going to show you an important way that we start working with time in Unity. So Unity actually has a bunch of features built in that we can use to solve these problems. So let's go back into our player controller script. And the first thing I want to show you here is something built into Unity. This is what's called a class, and we haven't talked about what a class actually is yet. You can think of a class as a script. So in this case here, public class player controller. This means our player controller script is a class. Think of a class as kind of a script or a group of code. Now Unity has tons of these classes built in that we can use. So instead of having to create all of our own code to do things, many things are already created. An example here is input. So this is a class that we're accessing getAccess on. So another commonly used class in Unity is one called time. And then once we're accessing a class like this, when we put the period or the dot and then something like getAccess, what we're actually doing is accessing one of these methods. So when we do input.getAccess here, it's almost the same idea as accessing a class like this one, except it's called input. And then we have a method kind of like start here, except it's called getAccess. So we're going to talk about that more later on, but that's the quick intro version of what a class is. For where we currently are with this project, that's going to be enough information to follow along, and then we're going to build on that as always. So right now we're accessing the time class. The first one I want to show you here is just called time. And then when we type in time, you see the description here. So it says time at the beginning of this frame. And what that means is if we put this here, we're not actually doing anything with it, but let's debug this out so we actually see it. So let's do debug.log. And then inside here, I'm going to put time.time. What this is going to do is at the start of every frame, it's going to display how long the game has been running for. So this is a way we can track how long the player has been playing the game. So if we go back to our game, let's open the console and run it. Now we're going to see it's constantly updating. And these numbers are in seconds. So now our game has been running for approximately 9 seconds, 10 seconds, 11. So we can keep track of that. So that's something that we can use throughout our game if we need to know how long the player's been playing, or say if you want to set incremental save points where say every 3 minutes you save the game. This is a way that we would be able to tell that. Now this one alone isn't really going to help us with our problem here of how the player moves too fast, and it moves faster depending on how the computer is running and how fast it runs. There is another one though. We're still going to use the time class, but we're going to look at it and there's time.delta time. Now if we look at the description of this one, it says the interval in seconds from the last frame to the current one. So if we select that, now we're going to debug this message out every frame. You're going to see a big difference here. So let's run our game now. And you can see it's a very, very small number. So 0.001 something most of the time. And it's always changing. What's happening here is, I'm just going to stop this, or actually I'll just pause it. And we're going to explain this a bit. So say this one right here. What's happening is it's saying from the last frame that the computer made to this current frame, it took the computer 0.0011528 seconds to create that frame and display it to us. So having this available is going to allow us to control how fast the player moves based on the frame rate, not the real time. So to explain that a bit better, let's look back at our code here. So currently right here, we're updating the transform.position every frame by a hard set value. So in this case, it's always going to be how much input is coming from the user multiplied by move speed. But we're not factoring in how long those frames took it all. If we change this and we start using this time.delta time, then we're modifying that. So to demonstrate this a bit, let's select our player. Now I have grid snapping on. So when I move, we're moving 1 unit. So a quick little visual here is, let's say we ignore a movement speed for our player. We just use the input. So when you press the button to the right, the player is going to move 1 unit. So if we do it currently, we're going to do that every frame. So if we say it takes 1 second per frame to render, which is a very high amount, that's not realistic, but let's use it so it's easier to think. The first frame, it's going to go from here to here, which is 1 unit. And then the next frame, it's going to go here, which is 1 more unit, and so on. So every frame or every second, it's going to move 1 spot. But say if we had 10 frames in that 1 second instead of 1 frame, that means this player is going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces all in 1 second when it should have only moved 1. That's the issue that we're having here right now. But if we add, just like we added a movement speed where we could control how fast it moves every frame, if we use that time.delta time, what we're doing is multiplying by the amount of time that frame took, which is a very small amount of time if the computer's running fast. So that means when 1 frame renders, our player is only going to move a very, very tiny amount. But say if that frame did take a full second, then our player would move 1 because it would multiply the movement by the time it took for that frame, which if it's 1, we're going to get the full movement. But let's say it's 0.1. So if it's 0.1, our player, let's turn snapping off, our player is going to move from -3 to -2.9. And then if the next frame took 0.1 second, it would move to 2.8. And then the next would be 2.7. So in that situation, if that happened, it would take 10 frames to move our unit 1 space. But if it took 1 full second for that frame to render, our player would still move 1 space because it's multiplying by that value. So I hope that makes sense to explain why this is going to happen. But let's go and actually change the code and let's see it happen in person. So we're going to take this time.delta time. I'm going to cut that. We'll just get rid of this. And we can keep our exact code that we have here. So we still want to check the player's input amount. We want to multiply it by speed. And now we also want to multiply it by time.delta time. Now let's go back to our game and you're going to notice something not expected here. So let's start moving our player. And I'm holding the right key, but the player's not moving. But if you look, it actually is. It's just a very, very slow, small amount. And the reason behind this is because we're still using this small speed amount. So I mentioned in the last video, this isn't something we want where it's this small. We had to do that to kind of compensate for time.delta time. So let's change this back to 1. Which essentially means we're not even using move speed. And let's see how fast our player moves now. So now it's moving, but it's still really slow. This is where we can actually use a move speed. So let's try 5. And now that's looking a lot better. So now with this new code, no matter how our computer runs or different computers that your game is on, our player is always going to move at a consistent speed. In this video, we're going to talk about something called an attribute. And we're actually going to talk about a specific attribute called SerializeField. So currently, if we select our player here, if we go down to our player controller script, so we have a player controller script. And inside here, we have a variable called move speed that lets us control how fast we move our player around. But every time we want to make a change to that, we have to go back into our script, change this value and save it, and then go back into Unity. Now, this isn't something you want to normally do because you want to be able to change this in the Unity editor. So a lot of the time you are going to see people where in front of it, they're going to add public. So you can do this. If I do this, and just like the name says, it makes this variable move speed become a public variable. And what that means is you can access it from any other script in your game. Now, there are great uses for public, and for a lot of things you do need to make them public. But it's good practice to only make things public when you need to. And at first, I'll admit I did make a lot of my variables public all the time because it was the easy route. But once you start getting a bit better at programming, you're going to realize that causes a lot of issues. When you create a bug in your game and you have to start troubleshooting, when you use public variables, it means that variable could be changed from anywhere in your game. Troubleshooting that means you have to go through all the scripts, you have to look for any place where you made a change. If we don't use public, that means anything that changes this variable has to be in this script. So if we're troubleshooting an issue, we instantly know it's going to be in the player controller, and then we can find it a lot easier. And that's just a really simple explanation. There's a lot of other reasons, but that's the big one I want to mention right here, because it will save you a lot of time to only make public variables when you need. Let's go back to our game, and I'm going to show you. So we made it public, and this does do what we want. So it adds here. So if we wanted, we could change the move speed to be 10 now. Then we run our game, and our player moves much faster. And we can actually change this while the game's running. So I can change it to say 4. And one thing to really stress and make note of here, when you change these variables while the game runs, make sure you always remember what it is, because when you stop the game, it goes back to what it was. It doesn't save those changes. And that's why I showed you earlier about this feature called Play Mode Tint. So it changes the color of our screen. So that really stresses, if this color is off like this, any changes I make are not going to save. So the reason behind this is you're able to change it while the game's running, so we can play test and we can find what works. So if I'm playing the game, I don't want to have to stop every time, change the speed, run it again, test it out. I want to be able to do it right here. I could go, let's change it to 6. Okay, that's still a bit too fast. Let's change it to 4. Okay, perfect. So now we found the speed we wanted without having to stop every time. And then we just need to either make note of it, or we could actually go to these little dots here and we could select copy component. And this will copy all the values we changed. And then when we stop, we could paste component values. So that's an option too, but when starting out, it's usually only one thing you change at a time, so it's easy to just remember them. And the reason this doesn't save while we're running the game, it might seem like something you would actually want it to do, but we couldn't do that because as we're running our game, things are always changing based on the game, the buttons we press. So for instance, every time I'm moving the player, notice the transform's changing. So if we saved that every time when we stop the game, every time I stop the game, all of our objects, our player, our boulders, our enemies, they would be in a different spot every time. It would save all of that data, so we can't do that. So let's get back to the content of this video. As I mentioned, this is a way we don't want to do it because now everything could access this. So let's remove public. Let's save it. If we look back in our game, we're going to notice, okay, it's gone again. So anytime you don't see public listed next to a variable, it's what's called a private variable. So it's the same thing as putting this private word, but you don't have to put it. It's by default. So for instance, input X is a private variable, even though we didn't put it here. For anything that you don't specifically need to be public, this is what we want. We want it private. So it's up to you if you want to put the private word there. I personally do actually like putting private just so it's very explicit and clear, but it makes no difference on how the code runs. So that's your preference. So private is the default. If you want to make it available to anything else, we add public. But if the only reason we want to make it public is so we can change it in the inspector while we're running our game, we have something built into Unity. These are called attributes. So we put an open square bracket, and then it's called SerializeField. So if I start typing SER, it's going to come up here. If I just click this one or finish typing it, put a close square bracket. Now if I save this, what this means is it's what's called serializing this variable, and that's a much more complex thing of explaining what serializing is. But for our sake, what we need to know is serializing this means it's available inside the inspector in our game. So now let's go back to Unity and see this. There, our variable's back. We can change it just like we did previously, except it's still private. So nothing else can access this, nothing else can change it. That's the way we want to keep it. And for a quick example, you're going to learn about public variables later. We are going to use some. But the reason you do want to make things public is look at the input class that we used here, for instance, input.getAccess. This getAccess one, it has to be public for us to access it because, as I mentioned, when a variable is private, we can only access it in the script that we're in. So for this instance, move speed is inside player controller. That means only code inside here, anywhere in player controller, can access move speed. So when we do this input.getAccess, because we're not in the input class or the input script, normally if this was private, we would not be able to do .getAccess. The reason we can see that is because it's a public variable. So if any of that stuff is confusing at this point, I apologize. I tried to keep it as simple as I can, but we are going to get into that more. That's more advanced topics that are going to come up later. But I want you to just kind of know what's coming and why we're doing some of this. There is logic in the order that we're presenting it here. So you kind of get it in little bite-sized chunks. Okay, so now you know any variable that you want to change in the inspector, you just put SerializeField in front of it.